Very good morning, students. Today we'll see a small portion from distributed system fifth unit. Here we are focusing on distributed shared memory. So first of all, let me discuss what do you mean by distributed shared memory. Distributed shared memory is a resource management component. So it's a resource management component of a distributed operating system, which implements the shared memory model in distributed system. So when we say it is a distributed shared memory, there is no physically uh, no shared memory. So the shared memory model provides a virtual address space that is shared among all computers in a distributed space system. So virtually we will feel that there is a shared memory. So that is what happened in this distributed shared memory. So now let's see the diagram so that you can have a clear understanding. So here what are the layers there? We have various process. Process actually invocate memory through memory management. So the via memory management manager response is received by process. So invocation response, that is the two message communication happen between memory manager and process. And this memory manager literally they are communicating shared virtual memory. So this is the overall structure. So from the diagram itself, we can clearly understand that it gives the illusion that it's a single memory. So programmer access the data across the network using only read and write primitives, right? So message passing is the will play a vital role in the distributed environment. So programmer do not have to deal with send and receive communication primitives and the complexity of dealing explicitly with synchronization and consistency in the message passing model. So that is the one advantage. Then a part of each computer's memory is earmarked for shared space and the remainder is private memory. Yeah, definitely we can hold one portion of the memory as a private one and one portion we can share it with other fellow processes. That is also possible. So to provide programmer with the illusion of a single shared address space, a memory mapping management layer is required to manage the shared virtual memory space that is depicted in the diagram very clearly. Now we'll see the advantages of distributed shared memory. So first one is simplifying the task. So communication across the network is achieved by the read or write abstraction, or we can say the read or write primitives that simplifies the task of programmers. So that is the major advantage. Then a single address space is provided. So definitely by providing a single address space, the possibility of avoiding the data movement across multiple address spaces is available, and we can simplifying the passing by reference concept as well as passing complex data structure which contain pointers. So that those things can be simplified with the help of the single address space. If a block of data needs to be moved, the system can exploit locality of reference to reduce the communication overhead. So end of the day, communication overhead also reduced. Um, Distributed shared memory is economical than using dedicated multi-process system because it uses simpler software interfaces and off-the-shelf hardware. Yeah, definitely. When we try to share something with other networks, we don't need to hold separate facilities, right? So automatically, we don't need to have a separate memory. Instead, we can have a common shared memory that can be accessed flawlessly by all the processes. So definitely, it's going to be economical. There is no bottleneck presented by a single memory access bus. Distributed shared memory effectively provide a large in the sense virtual main memory so that we can accommodate complex programs. Distributed shared memory provides portability of programs written using distributed shared memory. This portability arises due to a common DSM programming, that is distributed shared memory programming interface, which is independent of the operating system and other lower level system characteristics. So what will happen when multiple processors wish to access the same data object? A decision about how to handle concurrent process or concurrent access need to be made. If concurrent access is permitted by different processes to different replicas, the problem of replica consistency need to be addressed. So care should be taken when we are using the shared memory. That's why we are studying a lot of stuff like critical section, mutual exclusion, and so on. Okay, so these are the major advantages. Next one is challenges. Challenges in implementing replica coherency in distributed shared memory model. So programmers are aware of the availability of replica consistency models and from coding their distributed applications according to the semantics of these models. As distributed shared memory is implemented by asynchronous message passing, it faces the overhead of asynchronous synchronization. Since the control is given to memory management, the programmer lost the ability to use their own message passing solution for accessing shared objects. That is also one of the major challenge when we are dealing with replica concurrency in distributed shared memory systems. Still, some issues are there when we are designing the distributed shared memory system. So what are the things we need to focus when we are designing the distributed shared memory? Is determining the semantics to allow for concurrent access to shared objects, because parallelism is very important. And by implementing parallelism, we can avoid unnecessary congestion, overhead, etc. Determining the best way to implement the semantics of concurrent access to share data, either to use read or write replication. You can do either read replication or write replication. Selecting the location for replication to optimize efficiency from the system's viewpoint. Determining the location of remote data that the application needs to access if full replication is not used. So definitely we can able to determine and track the location of the data, remote data. That is also we need to take care of, because in a distributed environment everything is scattered, right? Once we know the proper location, then only we can able to do necessary changes. Reducing communication delays and the number of messages that are involved under the covers while implementing the semantics of concurrent access to shared data. That is also one of the things we need to consider when we are designing a optimistic distributed shared memory. So these are the concepts behind distributed shared memory. Thank you for listening.